Hello everyone, my name is Annie. Today I'm gonna show you how to make a EVI map using Google Earth Engine and how to classify it into a 4 or 5 class based on its value or yeah. First, what is AVI? AVI is a remote sensing index derived from satellite imagery designed to quantify vegetation growiness and biomass. It's an optimized version of the NDVI and offering improved sensitivity in high biomass areas and better performance in atmospheric conditions and dense vegetations. And what is the formula of the EVI? So, for NDVI, we use the NIR bands and red bands. But there is another bands, it's blue bands for atmospheric correction. So the influence of the atmospheric, it will be uh, low here if you compare to the NDVI. This is the formula, and there is for canopy background adjustment too, because it's this indices is very useful for um, dense vegetations because there is a canopy background adjustments. And here I will divide the AVI into 5 class. And first, you should know that AVI is similar with the NDVI value. The range is from -1 until 1. And if you want to classify it less than 0, you can say it or indicating it as a non-vegetated area or water, and from 0 to zero point 0.2 is bare soil or very sparse vegetation. From zero point 0.2 until 0.4 is you can indicating is as a grassland or sparse crop, and from zero point 0.4 until zero point 0.6 is moderate vegetation, and zero point 0.6 until 1 you can say it's are indicating it's dense or healthy vegetations. And what is the advantage and the limitation if you compare with the NDVI? Because these two indices you can use for vegetations if you want to do monitoring with the relate to the vegetation. These two indices is very useful, but there is advantage, or there is, if you compare to NDVI, EVI is more responsive to canopy structural variations and providing better insight into the complexity of vegetation cover. So if you want to do the monitor, or you want to see the canopy structural variations between 2 or 3, or in your area maybe there is 2 or 3 type of the tree or vegetation, you can uh, differentiate them. And the second is incorporate the blue band to correct for atmospheric influences, resulting in more accurate measurement, especially in region with the varying atmospheric conditions. Because of these blue bands, uh, the atmospheric condition is we can reduce the atmospheric influence and maintains the sensitivity in high biomass regions, allowing for better differentiation of vegetation density in forests and heavily vegetated agriculture area. Designed to minimize soil background effect, because I have already mentioned before, because there is L for the uh, soil background effects minimized, and making it more reliable in area with the exposed soil or varying soil type. And the limitation is more complex calculation compared to in DVI and require blue band data, which is maybe not available in all sensor. Maybe less effective in areas with the sparse vegetations. So this is the, if you want to use, or which area you can apply it. For example, for crop health monitoring, you can use these indices. And if you want to do the yield predictions in your agriculture, it's very useful too, because um, biomass is strongly correlated with the estimate the crop yields, because yeah. And you can prediction with these indices. And irrigation, the other application you can use in irrigation management or crop penology tracking. In forestry, you can track the forestations or monitor the forest recovery after disturbances. And or in environmental monitoring, you can use for study like changes in vegetation cover, or assess the impact of climate change and monitor the biodiversity. So there is so many application you can use these indices. Now I will show you how to uh, make map or get the EVI value using Google Earth Engine. First, you should have a account in this platform, and after that you can sign in and go to code editor here. And after that, in code editor, first you should define your ROI or area of interest. Here I will use my ROI from Indonesia, my country Indonesia, the Mark Regency, and make a center object and add to the layers. ROI. Okay, make it zoom, for example 10, and then run it. Okay, this is my ROI. And then find uh, your data set. Here I will give you example. I will use data from Landsat in 2024. So what is in Landsat 8 is you can go to the surface reflectance. And after that, here we will use blue bands and a red band and another band. So we will use band number 5, 4, and band number 2. And just go here. So just copy this snippet here, and filter bounds with your ROI, and filter that with which that or which year you will use. Here I will use 2024 January until 2024 December. And filter cloud, I will use less than 10% here. And this one for radiometric corrections. So if you go to these data sets, you will get this scale and this value, offset value. So you should multiply with this scale and add with this value. Here I will already multiply and add it, and I will rename band number 2 as blue, and band number 4 as red, and band number 5 as another bands. And this one is for calculate the AVI that I have already show you in my PPT. And then I will get the median value. And here's is I have I will add this AVA with median value to the layers. And let's run it. After a few moments, you will get the EVI map for your ROI. Here's if you want to know the value in the point, every point you just click, go to inspector and click here. So here's you can see that, for example, here's yeah. the value is 0.36. It means the for the classification is grassland or sparse crop. So that's if you want to know. Or here's the AVI is minus 0.06. It means or indicating with the um, water body or non-vegetation area. If you want to do the classifications, okay, based on this classification, I have already make a code for this classification. That's EVI less than zero, it's non-vegetated area or water, and zero point 0.2 until 0 to zero point 0.2 is bare soil or very sparse vegetations, and until zero point 0.4 is grassland or sparse crop, and zero point 0.4 until zero point 0.6 is moderate vegetation density, and more than zero point 0.6 is dense or healthy vegetation. And then after that, here's this code is only for the legend in this window. And then after that, this one, if you want to um, add your image to your drive, just run it, and after a few moments you will get the three layer here. This one is ROI, my ROI, and this one is the median value, and this one for the AVI classifications, which is the blue colors is water. So here is water because it's less than a zero, and red color is bare soil or sparse vegetations, and yellow color is grassland or sparse crop there, and this light green is moderate vegetation, and this dark green is dense vegetations. So I hope you can learn something from this tutorial, and maybe you can use these indices for so many application there. You can modify the code, and if you need the code, you can find it in my description of this YouTube channel. And thank you very much. I hope you can learn something. See you.